Alrighty then, so 14.2 states that an object is on a frictionless horizontal surface and attached to a spring that is displaced or compressed and then released so that it'll oscillate. And we're given that the original displacement or compression is 0.12 meters. And after 8 seconds, it's moves forward or is displaced in the opposite direction another 0.12 meters. So the first part of the question asks us to find the amplitude. And the amplitude is simply the minimum and maximum displacement for the object that we're looking at that's oscillating. And in this problem it's actually quite simple. We know the minimum and maximum displacement right off the bat. It's actually given to us. So our amplitude is actually 0.12 meters. You can kind of look at it as this line right here is the original state of the spring, right? So then it's compressed by 0.12 meters right here, goes up to rest, and then back up to 0.12 meters for its displacement after it's released, and then it goes back down to rest, and right here is our amplitude. And then part B asks us to find the period, and this one you kind of have to think it out first and then solve for it. So you can look at this period in a kind of a cyclical fashion. So we have starting from rest at point A, our spring is compressed 0.12 meters to point B, and then goes back to rest at point A. So this right here is a whole period. And we know from the question that it takes us 8 seconds to get to point B right here. So right here, this whole section takes 8 seconds, and that is half of our period. So we know that our period in general is equal to 2 pi. So we can say that half of our period is equal to our 8 seconds. 0.8 seconds, excuse me. So 0.8 seconds is half of our period. So then our period is simply 1.6 seconds for this to go back to our starting position. And then then we're asked to find the frequency in this same problem, and we know that our frequency is 1 over our period just from the equations in the book. So we have 1 over 1.6 seconds is equal to 0.63 cycles per second, or hertz.